The time has come. The time for me to build a 386 computer. I got this motherboard on eBay for a pretty good price, and it looks to be pretty much what I was looking for to do this build. It came with a 386 DX25 CPU. However, these chips are marked 33 megahertz, and that clock chip right there is marked 66. So I'm going to assume this board is running at 33 megahertz. So I did get a 386DX33 CPU that I will be putting in there, and I also have a 386 or 387 33 megahertz floating point processor, math coprocessor. This board also came with a lot of memory already in it. I don't know if any of that is good. I don't know anything about this board. I don't even know if it posts. The seller said that it does post. Hopefully it does. So I'm going to be testing that today. I brought some cards out of my collection to use in this build. We have a couple of multi-IO cards here with a serial and parallel port and some IDE and floppy ports on there. I don't know if either of these works. I'm going to assume that at least one of them does, so I'm going to be using those. We have the 3COM Etherlink 3, the 3C509 Ethernet card. Very reliable card that I've used in a number of builds, always works. We have the Zane ET4000AX video card. I've used this card before in a different build and replaced it with a different one, but this is going to be probably one of the best cards to match with this CPU, given its speed. In the benchmarks that I've looked at, it pretty much maxes out the ISA bus. I'm going to be doing some compatibility tests. I've heard some things about certain games not being very compatible with it in DOS, but I may be able to make them work. But if not, I do have other cards that I can try. So I may do some benchmarking and see where the bottleneck really is for the 386. And then for sound, I have the Sound Blaster 16. Good old reliable SB16. And you may ask why I'm not using an SB Pro or an SB Pro 2. And the answer is because I do not have one and they are very expensive. So the SB16 will work just fine for what I need it for sound. In terms of storage and disk drives, I have a CD drive here, a regular IDE CD drive that I'm going to be using. And I have a couple of floppy drives. I can't remember, one of these may be a 720K, but I think I'm going to try to put 2 drives in there. And if one of these is a 720, I'll just use one of them. And then I have these 3 IDE hard drives that I'm going to be using one of these. This one here is a Quantum 5 gigabyte or 4 point something. This one here is, I don't know, 500 megabytes or something like that. And this one says it is 255 megabytes. And I think all 3 of them work, but I cannot remember. So whichever one of them works and is maybe a little bit lower capacity, and I don't think I want a 5 gigabyte drive in there. I can't remember. That might be a 1 gigabyte drive. In any case, it's a 386, so this was the beginning of IDE, the early IDE drives, which were not very high capacity. One of these would probably be more period appropriate. I want to have the real spinning hard drive in there, just for correctness. And the case, I have this case right here. It's a pretty generic, regular old AT case. It has that CD drive in it, which I'm going to be removing and replacing with this one here. Yeah, nothing much here. It's got the AT power supply in it already, and all the buttons and lights ready to go. Yeah, so this will be an interesting build. I've been needing this a computer of this tier for a while for programming projects and games, other things that I want to do on a 386 class computer. The 386 is a really interesting CPU that doesn't get a lot of usage, I think, a lot of the time, because it kind of straddles the gap between the 286 slash 8088 era, the 16-bit era, and the 486 slash Pentium era of the 90s. A lot of people had 386SX computers, which was a pared down version of the 386DX that we have here, which had a 16-bit data bus going to the CPU, despite the CPU being 32-bit internally, which hamstrung it significantly. And I think the 386SX were clock for clock, even about on par with the 286s, the better ones. So they didn't, there were a lot of 386 computers out there, but for somebody who's building a PC like this, you might decide to go with a 286 or a 486. But I wanted to build this because it's an example of kind of one of the lowest tier, fully 32-bit computers that you will see out there. A lot of people have 486s, fast 486 DX2 or DX4 or Pentium machines, and those are just, once you get into that era, you're in a whole other tier of stuff, and you start running Windows 95 and operating systems that are more advanced than MS-DOS. But this will be pretty much a MS-DOS centered build. MS-DOS centric, very focused on what MS-DOS can do and what you can do in MS-DOS with the power, the added power of a 32-bit CPU with DOS extenders and that sort of thing. And but with it still being a pretty slow CPU compared to the later 32-bit CPUs. The 46 was an order of magnitude faster, the Pentium even more so. So it is a slow CPU, but it'll be fun. It'll be fun to play around with and maybe do a little bit of programming on and try to see what games play on it and how much performance we really can squeeze out of a 386 with one of the best video cards and sound cards that you could get in 1989 or 90 or 91, that era, just prior to when the 486 really became popular. So yeah, I think it's about time to get ready here and start cleaning these boards. They are a little bit dirty, so we're gonna clean them off, dust them off, and look at what we need to do here. There are some quirks. For example, this does not have an embedded PC speaker, so I'm gonna have to add one to this case. I do have one of those. Let me see. There's no embedded I/O. Those are added by the serial and parallel port components on those cards there. Let me see. In addition, there is also no CMOS battery. There, I think, are pins on here somewhere for the battery. Oh yes, there they are, right there. So I'm going to have to build a CMOS battery. I'm probably going to use I don't know if it's going to be 3 volts or 1.5 volts. It probably is 3 volts, but I'm going to look up the manual for this motherboard and find out. And make sure I do that correctly. I'm going to build a little battery with one of my battery cases, a couple of AAAs or something like that, and put that in the case with the motherboard to keep our CMOS settings. Before I power this board on, I'm going to remove all the RAM. I'm going to clean everything. I'm going to remove the CPU that came with it and make sure it's in the correct orientation. I don't know at all if it is or not. I assume it is, but we're going to find out about that, and then we'll do a little initial post test with this thing to make sure that it actually works after we clean everything. So yeah, I think we'll get started on that. it's time for this 386DX33 CPU. I don't know if you can see here, but it is a DX33. Somebody marked it good in 1996. We're gonna find out if it's still good. I'm gonna go ahead and put it in the socket. The old CPU was, in fact, correctly positioned in the socket. We're gonna go ahead and put it in there like that. You can see these old, they're called low insertion force, I think, sockets, and you could put it in raw if you wanted to. There's nothing stopping you from doing that. You will destroy your CPU and or your motherboard, so you don't want to do that. What you want to do is look for this little notch here on the edge of one of the corners. It will match up with this notch right here, so you know which way to put it in. So we're gonna put that in. Just slides right into the socket. Make sure it's in there. No heat sinks on these old pre-Pentium CPUs. Even the Pentiums didn't really need heat sinks sometimes, depending on how fast they were running. But yeah, so I think the next thing I'm going to do is look up the manual for this motherboard. Make sure I'm not missing anything with the clocks and the jumpers or anything. There doesn't really look like there's any real jumper settings on here. Looks like it was pretty much designed for one CPU, and I'm going to guess that that is the 386DX16 or 33 megahertz CPUs, given that the main clock crystal here is a 66 megahertz. So yeah, I'm gonna go take a look at that manual and see what I find. Well, I found the manual for the motherboard, and you know, there really isn't much going on here. This is pretty much it. We got external battery, turbo LED, and switch, power LED, speaker, reset switch, and we got our RAM configurations, and the turbo switch open and closed. So it looks like, well, that's something to do with the turbo switch, whether you can configure the turbo speed from the keyboard. Well, as far as this external battery connector goes, I'm going to have to do some experimentation with that. I did a little bit of research, and it doesn't look like any CMOS battery motherboards ever want a 1.5 volt CMOS battery. It's probably all 3+ volts, sometimes 4.5, sometimes even 6 volts. I know that this is actually the same connector that the motherboard in my IBM PC-AT uses, which is a 4.5 volt battery. So this may be expecting 4.5 volts, I don't know, but probably what I'm going to do is figure out which one of these pins is ground and which one of them is positive. I can figure that out fairly easily just by looking at the traces. Figure out which one of them, or figure out whether or not this thing is trying to charge from this connector. If so, then I'm going to have to use rechargeable batteries and make sure I have the right voltage somehow. Probably I would use 4.5. If not, then I'll just use regular alkaline batteries. I hope it's not trying to charge from this connector. I think a lot of these were made for a non-rechargeable battery, but you just never know. I don't see any place on this motherboard where you could add a regular one of those little barrel batteries that they used to put on these. I don't, unless I'm totally missing it. I don't see that anywhere here. So I'm going to assume that it was just purely the external battery. But in any case, we're just about ready to put this thing in the case, hook it up to the power supply, and do an initial post test. ready for the first post test of this motherboard. Let's give it a shot. And we have post. How about that? And would you look at that? We have 2 full megabytes of RAM. Yeah, I think I'm gonna want to upgrade that. Let's see. If it has 2 megabytes of RAM, what does that mean based on these documents? 2 megabytes. Yeah, it looks like each one of those sticks is 256 kilobytes. I have a giant sack of old sim RAM sticks, so I think I can upgrade that to at least 4. I think a 386 probably should have at least 4 megabytes of RAM, maybe 8. 8's probably the sweet spot for a 386. Well, none of our settings are going to save here since we don't have a battery connected, but we'll go ahead and go into the CMOS and see what that looks like. Yeah, this looks familiar. Yep. Once I get the I/O cards in there, I'll be able to set up the hard drive, probably directly from the BIOS here. I don't think I have to do anything else. All right. Well, the motherboard is working, so I think it's about time to get all of the other stuff in there. Alrighty. Well, I have the disk controller card with the I/O in it. I added another serial port using one of these little extra ports here. And I also added the Ethernet card in between, since the I/O card was a little bit of a tight fit against the video card. I didn't want those cables getting punctured. And I added the PC speaker, and I think I hooked it up right, but I don't know because there are no pinouts or anything on the manual for this motherboard, so I don't really know what's there. It's going to be some trial and error, I think, getting all of the stuff that I have to plug into the headers working, the LEDs and whatever, but this should be good enough. Oh, I added a floppy drive here, and I have no hard drive yet. I've got these, I've got power and an IDE connector here, ready to go to test some hard drives. So this should be enough to just boot good old trusty MS-DOS 5.0 and see what we got here. Still no CMOS battery. That's another project I'm going to have to do here, but this should get us pretty far. Well, I got to plug the power in. Hold on one sec. All right. We're going to see if she boots. Uh-oh. That didn't sound good. Hey, well, we have ourselves a PC speaker. Let's set this to the correct floppy drive. not bother setting the date and time here. Well, let's see if we can boot. Nope. Drive not ready error. Well, do some troubleshooting. Alright, as it turns out, I had the cable in upside down. There are two notches on the connector on that floppy drive, one on the top and one on the bottom, so can't rely on those notches to tell you what's what. I had to look at the numbers, the numbering on it, and find out where pin 1 is. So, we're going to try this again. Here we got a little RAM count. Let's see if we got boot. Non-system disk. Oh, I'll tell you why that is. I know exactly why that is. Oh, I kept my CMOS settings. How is that possible? Maybe because I didn't unplug the power supply. That's funny. Let me try a different boot disk. We're going to try my custom MS-DOS 7 boot disk. That seems to be booting just fine. I wonder if putting the cable in backwards ruined this disk. You know what? This one might be a 720K disk, or drive, I mean. That's possible. I don't know how we would know that, because this is a 1.44. This one is a 720. The one that's in there is a 720. Well, we got ourselves an A drive here. Well, I looked this one up and it's an 850 megabyte drive. That's a little bit too big. I think I'm gonna have to hope that this Western Digital works. It says AT compatible intelligent drive, 255.9 megabytes. Alright, we're ready to go with the Western Digital Caviar 2250, 255.9 megabyte drive. Uh-oh. I can feel it trying to spin up. There it goes. That was weird. Oh, that may or may not work. We're gonna find out. Okay, let's enter the CHS settings for this drive. Yeah, 244 megabytes. Okay, all right. We're gonna see what happens if we do that. Hard drive controller failure. Well, that's not good. Well, I don't know. Maybe that drive is bad. Let me find out if this one works. Yeah, 813 megabytes. I don't know. I don't know if we'll be able to address all of that, and we're going to find out, I guess. Right, we got the floppy disk in there. We're going to boot from it. All right, let's see if we got a C drive here. What we do? Oh, my goodness. Yeah, this is a bunch of my old stuff. Okay. Okay, now it's going to format for us. Alrighty, we got our formatted drive now with MS-DOS on it. Cool. Alright, we're gonna see if it boots from that. And we got boot. Right, we are well on our way to getting this thing working. Alright, well, I have a little bit of an update here. Since I got this drive working, almost immediately afterward I heard a scraping noise and, well, the heads crashed and drive spun down and stopped working. After that it would spin up a little bit when you turn on the machine, and then it would start scraping again after a little while and then spin down again. So this drive is done for. Oh, maybe I'll open it up at some point and take a look at it. See what's in there, just out of curiosity. But for now, I actually got this drive working. Believe it or not, the reason it was throwing a disk controller error was, I guess, because the jumper settings were set to master instead of cable select. So I set it to cable select, and here we are. It seems to be working. I went ahead and I created a partition, formatted it, and checked this doesn't return any errors. We've got 244 megabytes of FAT16 here, so I think I'm going to go with this for now. For now, we're going to go with this. So I think what I'm going to do right now is I'm going to copy over the DOS system files from my two DOS 7.1 floppy disks. Alright, there we have our basic DOS installation. I'm missing a whole bunch of stuff because I don't have everything on these floppy disks, but I have a lot of it. Got most of what I need here. I'm missing DOS key, which I would like to have, but yeah, there's a lot of stuff here. I do have the CD drivers here, so I'll be able to set up that CD drive once I get that in. Alrighty, I forgot about the CMOS battery conundrum. These two wires, I believe, should be positive and negative for the CMOS battery. One of those terminals I determined goes to a diode on the motherboard. The other one goes apparently to ground. Alright, I've done a little bit of soldering work here. I have soldered up a small AAA battery pack, making 3 volts here with a couple of AAA batteries. Alright, we're going to power on here. Hopefully we don't see any magic smoke coming out of any chips here. CMOS battery state low. Oh. Alright. I think I can take a hint from that. It probably wants 4.5 volts. Alright, we got the 3 AAAs in there and 4.5 volts. Hopefully this works. We're going to find out here. Let's turn it on. And we didn't get the low battery warning, so I think we might be good. CMOS system options not set. Well, it is several days later, and I have a little update on this project. I received some packages in the mail. I now have several 1 megabyte SIM, 30-pin SIMs. So hopefully I should be able to make out of these and the 3 or 4 good ones that I have. I did find another, by the way, and I've got it in there now, but it's mismatched. should be able to make 8 megabytes out of this. At least I'll make 4, which is what I do have in there. I did find that other stick there, but you know, it doesn't match. I'd like them to all match. That would be nice. So I've got those. I also have a more compatible VGA video card. This is a Western Digital Paradise WD90C11, as you can see there. This is, I guess, kind of the mid-tier Paradise card. There is a lower tier, which I have one of those that I think is a little more suited to a 286 class machine. I think this one will be better for the 386. And the benchmarks I was looking at, which were being run on a AMD K6, much faster than this, so as not to bottleneck the video card with the CPU. This card was right on top, pretty much maxing out the ISA bus, right up there with the Zane ET4000 and the other Western Digital top tier cards. All right, video card replaced with the Western Digital, and here it is. It's working. There's hardware info showing me Western Digital, and we got 512 kilobytes of VRAM. This is good. The Zane was not very compatible. I know that it has issues with certain games, because I've tried it before, and it did have issues with actually hardware info. The program would pick up what it is, but the text would not display correctly. All the text in hardware info was flashing. So I'm sure that's a hardware info issue, you know, supporting that video card, but I just know that the Zane cards are not as compatible. So I know Western Digitals are in my experience, more compatible, or compatible with everything that I've thrown at them. So figured I'd get a fast one of those and call that good. We got 512 kilobytes of VRAM, should be plenty for what we want to do. I don't know if that'll allow us to do 640 by 480, 256 colors only, or if we can do 800 by 600, maybe 16 colors, or maybe 256. I'm not sure. I'm gonna have to look that up, but I know that's twice as much VRAM as the original IBM VGA card had. So, all right, we're good on the RAM, we're good on the video, we're good on the hard drive with the hard drive controller, we're good on the floppy disks, and well, I think maybe next what I'm going to do here is I'm going to try to put in the Intel 387 math coprocessor and see if hardware info will pick it up. All right, one 387 math coprocessor, and this is a 33 megahertz chip to match the CPU that I got. This 387 I think I got from a recycle center a long time ago, and I've just been waiting to use it, so now I can finally use it. Put it in there with the notches lined up, so I'm not sure why there's an extra row of pins around the edge. Maybe for larger coprocessors, I'm not really sure. But the motherboard manual says that this is for a 387. I'm not sure what NPU means, but I mean, 8387, that's what it's meant for. So, yeah. We're going to power it on and see if hardware info will pick it up. It'll probably show up on our little boot up BIOS screen here. No. Numeric processor, that's what that stands for. Well, no is the answer. It's a little bit warm. It's not doing anything. Oh, you know what? I bet you I have to set this in the BIOS. Let's see about that here. Numeric processor. Right here. Present. Okay. Right to CMOS and exit. Now let's see if it works. And there it is. It says present. Well, let's go into hardware info. Okay, there it is. Look at that. 8386 and 8387. We are good to go. Okay. Next task is going to be to put in the Sound Blaster. And here you have it. The Sound Blaster 16 is installed on the machine. The hardware info detects it. There it is. If you have any issues with this later, I'll fix them, but I don't think I will. I'm pretty sure this card works, so I've got my PC speaker hooked up right there. And when I put the CD drive in, I'll go ahead and hook up the CD audio connector so I can listen to CDs while I'm working without using my CPU. How about that? All right, look at this. This is our CD-ROM drive. Got it in there, fit pretty well actually. We got the drivers for the CD-ROM loaded in here, and I'm gonna try, since this is a drive from 1995, it's pretty old. I don't know if it's gonna work with CDRs. So I'm gonna try it with both of these. We have a CD recordable that I made some while back. And then we have this copy of Star Wars Dark Forces. We're gonna try that one first. Okay. And there it is. So that works. And see if it will read that. I know that older drives oftentimes don't read CD recordables, but we're gonna try it and see what happens. Hey, there it is. I think the last thing is to do some cable management here and then put some drive bay front covers on there. Here we have it, the completed 386 computer with a 386DX 33 megahertz CPU, a 387 floating point coprocessor, also running at 33 megahertz, 8 megabytes of RAM, a 244 megabyte hard drive, a Sound Blaster 16 sound card, a Western Digital Paradise VGA video card, and MS-DOS. So I think it's about time to plug this into my main setup and test it out.
You